Good morning, I'm Dr. Huang. Today, I'm going to teach you a systematic method to write down the Lewis structures with resonance structures and formal charges. There are a lot of molecules and ions whose Lewis structures are very difficult to write down correctly. Here is a list of them. Well, if you can follow the procedures I'm teaching you here, it will be relatively easy and relatively fast to write down the correct Lewis structures with resonance structures and formal charges for any molecule or any ion. Well, let me use nitrite ion as an example to illustrate the steps of this method. The first step of this method is to obtain a skeleton structure from an instructor. This is the skeleton structure of nitrite. In a skeleton structure, a line or sometimes a dotted line tells us that there will be a chemical bond between the two atoms. For example, this line tells us that there will be a chemical bond between the central nitrogen atom and the oxygen atom on the right. However, a line or sometimes a dotted line in a skeleton structure is not always a single bond in a Lewis structure. It can also be a double bond or a triple bond. Let me summarize. A line or sometimes a dotted line tells us that there will be a chemical bond between two atoms. A line or a dotted line in a skeleton structure is not always a single bond in a Lewis structure. It can also be a double bond or a triple bond. The second step of this method is to place the valence electrons next to each atom. Each oxygen atom has 6 valence electrons. Each nitrogen atom has 5 valence electrons. You can find the number of valence electrons of any atom from a periodic table. Nitrite has -1 charge. Therefore, it has 1 additional electron. Now let me show you how I place the valence electrons next to each atom. You can start from any atom. Let's start from the oxygen atom on the left. From the skeleton structure, this oxygen atom has only one neighbor, which is the central nitrogen atom. Therefore, we will take one of the valence electrons of the oxygen atom and we place it between the oxygen atom and its neighbor. Then we will place the 5 electrons left from the previous step into 3 groups. The principle to place the electrons left into groups from the previous step is we will prefer to have groups of 2 electrons unless we have odd number electrons. If we have odd number electrons, we will have one group with only 1 electron. All the other groups should have 2 electrons. Well, we will follow the same principle to place the valence electrons next to the nitrogen atom and the oxygen atom on the right. Well, for the central nitrogen atom, from the skeleton structure, it has 2 neighbors. Therefore, we will need 1 electron for each neighbor. We will place one of the valence electrons of the nitrogen atom between the central nitrogen atom and the neighbor on the left. We will place another electron between the central nitrogen atom and its neighbor on the right. Then we will place the 3 electrons left into 2 groups. We will do the same for the oxygen atom on the right. Then you may wonder, Dr. H, where do we place this additional electron? Well, in general, we will place this electron next to the most electronegative atom in the molecule or ion. In this case, it should be the oxygen atom. However, this ion has 2 oxygen atoms. It seems you have to pick which oxygen atom you want to place this electron next to. Actually, it does not matter which oxygen atom you choose. Well, let's place this electron next to the oxygen atom on the right. Every time if you place an additional electron to an atom, you place a -1 formal charge next to the atom. The next step is to replace the electron pairs between the 2 atoms with a single stick, which means a single bond in the Lewis structure. Well, the next step is to make sure every atom must have either an octet or extended octet. Now let me explain what are octet electrons. Let me use oxygen atom on the right as an example. Octet electrons are the electrons we placed next to that atom. They include lone pair electrons and shared pair electrons. Lone pair electrons are not shared between atoms. Shared pair electrons are shared between 2 atoms. The lone pair electrons are counted as octet electrons only for one atom. The shared pair electrons are counted as octet electrons for both atoms. Let's count. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Well, remember, our goal is to make sure every atom has either an octet or extended octet. Because both nitrogen and oxygen, the valence shell is n equal to 2 shell. None of them can have an extended octet. Well, that means every atom should have 8 octet electrons. The oxygen atom on the right already have 8 octet electrons. That means the oxygen atom on the right already have an octet. The nitrogen atom in the center and the oxygen atom on the left only has 7 octet electrons. Therefore, we should have some way to increase the number of octet electrons for both atoms. There are 2 ways and only 2 ways to increase the number of octet electrons. One way is to borrow, which means we will take one electron from its direct neighbor and we place it next to the other atom. To borrow will increase the number of octet electrons for one atom, but it will decrease the number of octet electrons for another atom. Plus, it will create 2 formal charges. Therefore, we prefer to share electron pairs than to borrow an electron from its direct neighbor. To share means we will create another shared pair by each atom contribute an electron. This way, the number of octet electrons for both atoms will increase by 1, and it will not create any formal charges for any atom. Therefore, we prefer to share a pair of electrons between 2 atoms than to borrow an electron from one atom to its direct neighbor. We borrow an electron from its direct neighbor only if to share will create a Lewis structure that will violate one of the rules of the Lewis structures. Well, let's try to share first. When we share another pair of electrons between the oxygen atom on the left and the central nitrogen atom, the number of octet electrons for both will be 8. Well, this seems to be a reasonable Lewis structure. Let's replace this shared pair with another stick. This Lewis structure is a good Lewis structure because it does not violate any rule we have so far. This Lewis structure has 2 bonds. One of the bonds is a double bond. The other is a single bond. Remember, if a Lewis structure has 2 or more bonds and at least one of the bonds is a double bond or a triple bond, we should try to say if it has resonance structures. Actually, nitrite does have 1 resonance structure in addition to the Lewis structure we have. Therefore, nitrite has 2 resonance structures. Now let me explain how to get other resonance structures from the Lewis structure we just got. In general, all resonance structures should have the same number of bonds and the same number of lone pair electrons. The original Lewis structure has 1, 2, 3 bonds and 1, 2, 3, 4, 5, 6 pairs of lone pair electrons. Therefore, the resonance structure should also have 3 bonds and 6 pairs of lone pair electrons. 1, 2, 3, 4, 5, 6. The first step is to rearrange the bonds. There is only one more way to rearrange the bonds. We will place a double bond here, a single bond here. The next step is to place the lone pair electrons next to the non-central atoms to make an octet for each non-central atom. If you have any lone pair electrons left, you will place them next to the central atom. Remember, we're not done yet. You have to calculate the formal charge of any atom. Remember, to calculate the formal charge of an atom, you use the number of valence electrons minus the lone pair electrons minus half of the bonding pair electrons. From our calculation, only the oxygen atom on the left has non-zero formal charge, which is -1. Therefore, we will place -1 formal charge next to the oxygen atom on the left. Well, it seems we have found all resonance structures of the nitrite ion. If you are asked to give me the Lewis structure of nitrite ion during exam or quiz, this will be the answer I'm looking for. You must include all resonance structures with all non-zero formal charges labeled correctly. You also need to include a double arrow between the two resonance structures.